Welcome everyone to my LeetCode weekly contest 422 live stream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few minutes, we'll be doing the contest live, we'll be answering questions and giving hints in the chat, so join us every weekend for the contest. Remember, no code will ever be shared during the contest itself, but immediately after we end, we will go through answers for all 4 questions. So stick around, join us every week and work on the contest yourself alongside the rest of chat. If you enjoy LeetCode content, do check out the rest of my channel. I have videos on different problems as well as hardest question 4s of different previous contests. And as usual, like and subscribe to stay up to date on new videos. Alright. Okay, so I think we should be good to go. The contest is about to start in a few minutes, actually a few seconds. So once the contest is underway, remember that I code on a different screen than the one the contest is on. So don't be surprised if you don't see any activity on the screen. If you have questions, type in the chat. So don't be surprised if you don't see any activity on the screen itself. This is to ensure competitive integrity. We're not supposed, and anyway, you're not supposed to share answers during the contest. We will all get in trouble, and we don't want to do that. All right, contest is live. Good luck, everybody. All right. Let me see here. First question: you're given an integer array nums. Start by selecting a start position cur such that nums cur equals 0. Okay, we define something in movement direction of either left or right. By moving, okay. Else, if nums cur is larger than 0, decrease nums cur by 1. So nums cur equals to 0. Move it in. Okay, this is an English comprehension question. This question is not even programming, man. This is just straight up English comprehension. If cur is out of range, this process ends. If nums cur equals 0, move in the current direction by incrementing cur if you're moving right or decrementing cur if you're moving left. If nums cur larger than 0, decrement nums cur by 1 and then reverse direction. Take a step in a new direction. Okay, so you're sort of like bouncing around. It feels like you're bouncing around with this problem. So let's see if that makes sense. So let's say we start at here. We're gonna move to here. So 1 0 2 0 3. We start here, and then we move to the left to 2. So 2 becomes 1, and then we go back to 3. We change direction. When we hit a 1, we change direction. This one becomes 2, and it goes back to here. This becomes 0, and then it changes direction to bounce to here. Becomes 1. And then it changes direction and bounces back to here. Oh, interesting. Okay. Okay. This is almost like a math problem. The number of possible valid selections. So this one, there's only valid selection. If we have to start here. If we start in this 0, we can move in either direction and be good. Here, there are no possible valid directions. How do we know? Well, it seems like what we have to do is to bounce between two sides of the array. This is how is this? This is not 3 points. Okay, so basically it looks like we have to bounce between two sides of the array. So we start here. We will sort of bounce to the left, and then we'll bounce to the right, and bounce to the left, right, until they reach 0. So this will only happen if one side is equal to the other side plus minus 1. I think that's basically the trick. So think about it. If you start, so you start from here. You bounce left, bounce right, bounce left, bounce right. Basically, the idea is you start from a 0. You can go either direction. You go in that direction. You will set a 0, and then you reverse, go to the other direction, and set a 0. So it's almost, you think of it like Pong, like the game Pong, where you're bouncing left and right. Okay, so these 4s will cancel out. This 1 will cancel out with this 3 will become 2, and then you'll get stuck. So basically, it sounds like you're looking for a pattern. Right, so that's all the hints I'm going to give for this one. Think about it a little bit yourself. See if you can work it out on your own. And ask questions in the chat if you need help. This is not really hard for programming exercise, but it's kind of hard for yeah, it's kind of difficult for a the math is kind of difficult. Oh shit. Oh crap. I got a wrong answer. Wait a second. Huh, interesting. 10203. Hello. If I see folks in the chat. So if you just joined the chat, welcome. I'm gonna flash the question on the screen. So as a reminder, I don't show code during the contest. So I will show you the problem. So if you can either follow along on screen, try to work it out yourself and talk through it, or ideally try to work on the contest yourself in front of computer. If you have questions, make sure you type in the chat and I will respond to you. Okay. Huh, interesting. Oh, I see. Okay. Okay. So it's not just the valid selection is not just the starting position, it's starting position plus direction. So if your starting position can go in two directions, that's two different selections. Damn it. Lost 5 minutes because of that. Alright, next question. Zero array transformation 1. As usual, if I see two questions with the same name, I'll try to see if they are the same question but harder. If they're the same question but harder, what I'll do, but like bigger, I'll just solve the second question and ignore the first question. That's what I normally do. Okay, they look. Okay, so I think they look different. You're given an integer array nums of length n and 2D array queries, with queries I equals to L1 R1. For each queries I, select a subset of indices within the range in nums. Decrease the values at index selected index by 1. Okay? A zero array is an array where all elements are equal to 0. Return true if it's possible to transform nums into a zero array after processing all queries sequentially, otherwise return false. Okay, so basically you want to okay. And when you decrement, so this is interesting. So queries, basically when you decrement them, they don't go negative. So this is like 1, 0, 1, right? And you're supposed to decrement index 2, 0 to 2, so you decrement all three numbers. But the middle number, this index 1, doesn't become -1. It stays at 0. So it stays at 0. So basically what you want to do is you want to find like sounds like what you need to do is to find like the ranges, and for each one calculate how many times it's been decremented. It must make sure that the nums okay. So this is some kind of tree problem. Okay, let's see what the other one is. I want to see if they're the same problem. Okay, let me look at all the examples first. So this is 4, 3, 2, 1. Queries 1, 3, 0, 1, 2, 3. So you decrement 1. This becomes 4, 2, 1, 0. And then 0, 2, this 4, 2, 1, 0. After decrementing indices 0 to 2 will become 3, 1, 0, 0. 3, 1, 0, 0. It's not a zero array. Okay. Let's see what this... Oh, this is harder. This is harder, so we're not going to do that. Okay, I wonder if this is just by brute force, you know? If I can do it just by brute force. I don't think I can do it just by brute force. So brute force means I just literally just physically go decrement all the arrays. So one thing I can think of is I can sort these guys. I can sort these guys by I can basically sort these guys. So I can sort the queries. So basically what this question is asking for is these queries, they sort of form blocks. So for instance, 4, 3, 2, 1. I have one block that is like a 1 to 3. Sorry, 1, 2, 3. And then I have another block that is 0 to 2. And I want to know that these things, they are -2 because they are covered by 2 blocks, and these are by 1 blocks. So what I can do is I can sort these things. I can sort all these blocks from left by their leftmost. If I sort these things by their leftmost, what do they look like? Look something like this. And then what I want to do is, okay, at each point, okay, I sort them by their leftmost, and I keep the rightmost in some kind of I guess some kind of heap, right? And at each point I sort of count how many there are in this heap. Yeah, I think that's the way to go. I think that's the way to go. If I sort these queries by their start index, and I keep the right end index in some kind of heap. Okay, just out of curiosity, I want to see what is zero array transformation 2. So you're given an integer array nums length and a 2D array, okay, blah blah blah, the same. Decrement by at most value. Oh, so it's left right value. The amount by which each increment. Okay, I think it's similar. I think it's pretty similar. Okay, all right. So once again, no answers. Hi Harika, no answers to be given during contest. Try them yourself first. After contest, we'll discuss solutions. Yeah, sorry about that. You know, we want to make sure the contest is fair to everybody, so we don't give answers. No answers will be given. So try it out yourself first. And remember, I'm actually coding on the other screen. I may be quiet a little bit. It doesn't mean that I'm not doing anything. It means that I'm hard at work solving the problem. Definitely try them out yourself. This is actually quite difficult for for question 2. Normally question 2 is much easier than this. Hopefully question 3 is easy. Okay. This is the kind of question where you sort of have to ask yourself, what is the ideal data structure here? What would be the best data structure to use in a question like this? Hi, I have a logic for question 2. Hi, always fun. Welcome, welcome. First, compute the sum for the given query from L to R. We need to decrement a sum for the given queries from L to R. So the decrement value will be... Wait, hang on. Given queries from L to R, we need to decrement 1 from this range, so that the decrement value will be L plus R plus 1. I don't know if that's correct. Sum of array. Huh. Yeah. Actually, you know what? I think that's correct. I think that works. Yeah, I think that works. I think so. Sum of array. So you can do some... okay. Yeah, it sounds like you can do some kind of prefix sum. Is that what you're looking at? Yeah, some kind of prefix sum. I think that might work. Oh, it passes 621 out of 667 test cases. Is it timeout? Yeah, yeah. I'll have to see your code later. I'm also still working on it, but I'll have to see your code later. Well, good luck. Always fun. I hope you manage to do it. Let us know if you do manage to do it. It does look like some kind of prefix sum. Yeah. Yeah, I also ended up doing some kind of prefix sum. I started by doing a hash table, then I realized I really don't need the hash table. I just need to know when it starts and when it ends. And then I do a prefix sum. If num's larger than cur, I think this should work. Interesting. Oh shit. I also have ran into some errors. Yeah. I wonder if I have my errors are the same as yours. I wonder if my errors are the same as yours. So the error I'm running into is, yeah, so I basically did a prefix sum. So every time I see a start, I just add the number, and when I see an end, I decrement the number. But let me see. I might have a bug in my program. So six. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Okay. Huh, interesting. Okay, where did I go wrong? Cur plus equals to this. 6. Ran into a bug somewhere. So 3, 6. Oh, okay. Damn it. That's such a simple, obvious bug. Alright. Alright, cool. So I did question 2. Question 3 should be the same, should be very similar to question 2. There's just the addition of the value. I think it's the same, if I'm not mistaken. Solution has no min is 0 index. Okay, run. Index out of range. Okay, in nums by at most I. Okay. Question 2. If so shattered dreams. Sorry, I'm gonna ask you not to paste any code here. We don't share code here. Feel free to chat and discuss ideas, but I am gonna unfortunately have to remove your message. I'm sorry about that, Shattered Dreams. Yeah, sorry about that. Yeah, so sorry, because if you share your code and somebody copies your code, you're gonna get in trouble. So question 2, you don't have to do by sec tree. You can think of it. So the way I did it is by a prefix tree. So question 2 is basically you can try it by a prefix tree. So you know where the start and ends are, right? So for instance, this one, test case. This question 1. Question 2, yep. So for instance, this one, let's see the test cases. The test cases is let's say 4, 3, 2, 1, right? So ignore this first. Just look at the queries. 1, 3. You think of this as an array. You have 1, 3, 0, 1, 2, 3. These 3. So when you reach here, you get a +1, and reach here, you get a -1. Right? That's what 1, 3 means. 0, 2. Here you get a +1. Actually, the -1 is after the 1, 3. You -1 at the end. So 0, 2, this is 1, 3. 0, 2. At 0, 1, 2, 3. At 0, you get a +1. At 2, at 3, so 1 more than 2. 1 after this n number is a -1. So if you go over this logic, 0 will be 1. 1 will be +1, again 2. 2, do nothing, so it's 2 again. 3 will be -1, will be 1. So if your nums, if all the numbers in your nums are smaller or equal to this, then this will work. But try yourself. I'm not going to write any code here. Again, we don't share any code here. But see if you can follow the idea along and try to code along. Yeah, so okay, sir. Yeah, sorry about that. Shattered Dreams. Really appreciate you. Yeah, I hope so. WebSlick, I hope that was helpful to you. I hope that was helpful to you. List index out of, list array out of. All right. Huh. I'm not getting this. Oh, oops. So you're supposed to return the minimum possible non-negative value of k, such that after processing the first k interviews. Oh, interesting. Okay, I misunderstood the question. Non-negative value. First k, the nums become a 0 array. If no such k return exists, return -1. Okay, so this is a slightly different problem. Let me think about it a little bit. Yeah, let me think about it a little bit. So this is very similar to the first one, except that you have to return the minimum. So how many of these k's do you need? Okay, so what we can do, in this case, what we can do, is that for each, so it's a very similar problem. We also use a prefix sum, but instead of doing the sum, what I can do is I can say, I can sort of tag all of these guys. I can say this guy comes from index prefix from query I. This comes from query 0, and then I find the largest query that I need in order to make this work. So that's one thing I can do. Yeah, I'll try that. Okay, so for basically for each yeah. So I'm gonna modify. I'm pretty sure the right way is to modify from the previous one. So instead of just adding the value, what I can do is I can I can append a pair which contains the index len of queries yeah. Yes, should I add that prefix of yes to the nums array? Yep, pretty much. My question 3 is not submitting, only 2 test case failed. Yeah. Yeah, I don't know. I hate those like last few test cases because they are always some kind of edge case. I kind of hate those, to be honest. Yeah. Do you think it's a TLE? Is it a TLE or wrong answer? I'm curious. If it's TLE, probably it's trickier. If it's TLE, it's a bit trickier. But if it's wrong answer, then you know it is what it is. Okay. So it looks like WebSlick has a question. Okay, I feel like it's sort of pretty much the same thing. Huh. WebSlick, do you have a question? So if, well, I'll let you formulate that. I've never been able to do any question in segment 3. Yeah, I don't think this is not really segment 3. This is a prefix sum. Yeah, no, I'm glad you're able to do it. Nice, very nice. Congrats, Satyam Raj. Congratulations. Question 3 is similar to question 2. It's a bit trickier. Yeah, it's a bit trickier. Okay. I think I got question 3. Alright. Let me check on the how to do question 3. Line sweep algorithm. Wrong answer. Oh, you know what? I hate those. It's some weird, bizarre test case that you never think of. I would just go to question 4 and try it. I mean, I really hate those. You can, yeah, I really hate those. I don't know what else to say. How to do question 3, line sweep algorithm. I don't know what is line sweep algorithm. But question 3, I think is probably similar to question 2. So the way I did it is as follows. So it's very similar. So the main difference is this value actually doesn't matter. This is a very small difference. This just means instead of +1, it just plus value minus value. Instead of +1 and -1. That's like one line change. So minimum possible non-negative value of k, such that processing the first k queries nums becomes 0. So I think what you need to do here is you actually need to keep track of where all the where all the pluses and minuses come from. So for instance, let me see. So let's say this one, right? Let's say this one. This one, what you want to do is, you can say 0 to 2, 1. What you want to do is you have to remember this is at index 0. So it's 0, 0, 1, 2. So this is start, this is the end. There's a +1 here at index 0. And then at 3, at index 0, this Q means query. This 0 means that query 0. It comes from query 0. There's a minus 1. 1 because this is the value. And then next one, 0 to 2, 0, 1, 2. So same thing at 1, index 1, there's a +1 here. And there's index 1, there's a -1 here. And at the 1, 1, 1, 1. So it's 1, 1. So at index 1, there's a plus. So this is the third query. This is query 2. So this will be 2. There's a +3 here. And then 1, 1, right? So at query 2, there's a -3 here. And then what you want to do is then go through the same strategy as before. Now you have 2 0, 2. Yeah. So you go through. So in order for this to work, I need this and this. I need the two pluses. So we're good. In order for this to work, I don't need this. I don't need this too. So my sort of best, my best doesn't include him. And then in order this to work, I need the 2. So it's again I need 2. Yeah. So you only need 0 and 1. So this way you can keep track of not just what the maximum decrement value is, you also keep track of where those values are coming from. I hope that's helpful. Again, no code. Remember, there's no sharing of code. We'll just do hints. Yeah. All right. Let me try again. Still not working. This object cannot be interpreted as range of length of nums. Start is not defined. Once again, if you have questions, ask on the chat. I don't keep talking because I'm also doing my work. Also, I'm kind of behind. Damn it, I'm kind of behind. So I need to catch up a little bit. So I may not be talking so constantly. Well, IDX is smaller than best. Let me see. IDX is smaller than best. Okay, let's see if this works. Wrong answer. Damn it. I feel like LeetCode is more stingy with their test cases these days. They're more stingy with their test cases. It used to be that they'll give you a lot of test cases, and then if you run the test case and the test case is correct, then your program should work. But now I feel like sometimes the LeetCode they're very stingy with their test cases. Even if you run the given test cases, it will be wrong. So you have to waste, like, you take the penalty to actually test your code. So now you have to be a little bit more accurate, which is tricky. I generally don't care. I just take the penalty. So I get hit with a lot of penalties. So sometimes I don't do very well. But I want to do as many questions as I can. I'd rather finish all 4 questions, or finish 3 questions. I have a lot of time to try question 4, while taking penalty, than the reverse. All right, let me see what's wrong with this. This looks correct. Best is 1. No way. If this is the reason why it doesn't work, I'll be so mad. $417 out of 628. Damn it. Really? Come on. Why you gotta do me like this? Expected 3. Alright, let's print some stuff and see what's going on here. So 0, I equals 0, I equals to 1. Oh, interesting. So it has 7. Why is it 7? He's with 4, 6, 8. Okay. Let me see, at the end of this, why is best equals to 0? So 0, okay, that's correct. This is 0. Okay. I equals to, let me just look at the chat real quick. Okay, no questions. Once again, if you have questions, make sure you let me know. And while people are here, before the contest ends, just again a plug. If you enjoy this, if you enjoy the live stream and you have not subbed to the channel, here's a plug to sub. If you like the live stream but not enough to sub, no worries. It will help me out so much if you just click a like. Just click like on the video. It's gonna help me out a lot. Just click the like button. And if you want to really help me out, just comment. It improves the engagement numbers a lot and it helps other people discover. I got 625 pass, then time complexity error. Oh my god, Sriram Raj Kumar. Good luck, man. Yeah, I don't know. I feel like mine might also have time complexity error. Because yeah, it's supposed to be a medium. It's not supposed to be hard. Damn it. If it's a hard, then I might add like some kind of binary search or something, or some pre-processing. But if it's a medium, it shouldn't be this difficult. Damn it. Well, I got a bug, so I need to damn it. I got some weird bug. I need to debug a little bit. It's like one of those weird positional bugs. So index 6. Still wrong. What's wrong? What is best equals idx plus 1? Wait, I don't get it. Why is it 3? Oh, I see. All right. I think I have to. Oh, still wrong. What the heck? What am I doing wrong? Zero, 1, 2, 3. Oh, I'm doing something wrong here. Bro, hint binary search. Is it the binary search? So here's what I'm up to. Ah man. Here's where I'm up to. I'm also trying to do this. So what I'm doing is I'm going to each. As I go through the nums, what I do is I look at, let's say, this 2. I look at how many of these do I need in order to be 2 or more. So I need both of these. I start from the one with the smallest index. I need this plus 1 and I need this plus 1. So I need basically 1. So I need to 1 plus 1, which is basically I need 2. What you call it? I need 2 of these in order to. I need 2 queries in order to reach this 2 here. When I get to here, this is 0. My current running total is 2. So I don't need this plus 3 at all. So 0, I'm all good. So here, doesn't matter. Right? I keep going. Here, I keep going. So basically, question 3 is very similar to question 2. The difference is, instead of just aggregating all the numbers, all the increments, 1, the difference is it uses val instead of just plus 1 every time, which is a very small change. 2, and more importantly, you need to keep track of which query this val is coming from. So that's the thing that you need to do, because you need to find the minimum possible non-negative value of k, such that processing the first k queries in query will give you the right answer. I'll talk about it more after the contest. I'm also trying to finish up before the time. This is very unfortunate, I tell you. All right. Oh. Crap. It's not that easy. Yeah, it's not that easy. They grade query in a sorted way based on value. Wait, why do you sort based on value? Shouldn't you sort based on the index? Yeah, so you need binary search. Yeah. Yeah. So you need so you need binary search for the last step. So I think that's the I don't think I have time to do that. Yeah, very nicely done, Sriram Rajkumar. Very nicely done. Yeah. Do you do a binary search over this? Do you binary search over this thing? Wait. How will you do a binary search? Oh, so you compute the whole thing. I see. Wait. How do you do a binary search? How do you do a binary search and not make it n square? Because there are 10 to the power of 5 queries. So find mid and use if we find the answer, but you optimize by moving right to mid -1. Zero to mid. How do you find your value from 0 to mid? In like a cheap way. So I guess, let me see. So you probably want some kind of array, and then you want to update the array. But isn't that like n square time? Wait a second. Isn't that like n square time? Okay, so you've got all these queries, right? So I presume your How would you? I still don't. I think I still don't quite get it. Yeah. All right. Actually, I don't think I have time left to do this. I'm gonna look at question 4 real quick to see what it looks like. Yeah. Wow. I gotta think a little bit on question 3. That's tricky. So I feel like I can't get the binary search part. That's the part I'm not quite sure. So let me see question 4. You're given an array of integer nums. Some values in nums are missing and denoted by -1. You can choose a pair of positive integers exactly once and replace each missing element with either x or y. You need to minimize absolute difference between adjacent pairs of nums after replacement. Return the minimum possible difference. So if you choose 6 and 7, each with either x or y. Okay, so basically we want to replace every element by 2 numbers, x or y. And want to return the minimum possible difference. Let me see. Let me think about this for a while. I think I've pretty much given up on question 3 at this point. But let me think about this for a while. Let me see if there's something interesting here. So let's say 1, 2, -1, 10, and 8. So this and this is 1. This and 2. Yeah. So this and this is 8. The difference is 8. And there's one thing in between. So I can choose a number here that minimizes. Okay. So if there is, let me see. So I think the way it works is, because every -1 can be replaced by A or B. Basically, we're providing 2 numbers A and B. So if it's 1, 2, -1, -1, 10, 8, then one of them will be A, the other one will be B. So this difference is 8, this difference is 1, this difference is 2. So to minimize the difference between 2 and 8, yeah. I think this comes down to basically finding the intervals. Between. So these guys actually are irrelevant. These guys on the side are irrelevant. You don't care about them. You only care about the ones, the sequence of -1s. And it doesn't matter how many -1s there are, because all the -1s will be replaced by A or B. If they're replaced by the same number, then it's the difference will be 0. If they're replaced by a different number, then it'll be the absolute of A minus B. Absolute value of A minus B. So let's say it's 2 -1 -1 10. To make this as small as possible, I need to take 8, divide it by 3, and then add to 2. So 8 divided by 3 is about 3. So 2, this will be, I can do like 5, and this can be 8. So 2 and 5 is 3, 5 and 8 is 3, 8 and 10 is 2. So A will be 5 and B will be 8. Yeah, this is kind of tricky. This is kind of tricky. Yeah, but the other problem is, is that these things apply to all intervals. All intervals. Like this one, you know, if there's a 2 and a 10 here, then this difference is also, this guy will also have to be 5 or 8. So for example, somewhere down the line, there's a 100 and a -1 and 200. Then this thing will have to be 5 or 8. Yeah. So this is a bit trickier. I mean, it probably comes down to a few cases. Yeah, it probably comes down to a few cases. Like, I'll have to put all these things on number scale. Yeah, I have to think about it. I'm not super sure what this is. But, yeah, this thing, unfortunately, I don't think I can finish it in time. It looks like some folks managed to do it. Congratulations to Shriram Rajkumar. Anyone else who managed to do question 3, good job. The contest is almost over. Once more, the shameless plug by me. If you enjoy the live stream, I would definitely appreciate if you just click the like button on the video that you're currently watching. It's going to help me out a lot. If you don't like the live stream, you can leave a comment to tell me why you don't like live stream so I can make it better next time. Try not to click the dislike. It will really hurt me. But you know, if you really dislike it, well, go ahead. I would appreciate if you leave a comment. Let me know how well you've done in this contest. I feel like today's question 2 and question 3 is a little bit harder than the average. Usually question 1, 2, and 3 are quite easy. Okay, so the contest is ended. I hope everybody did well, or at least did as well as you would like to. You know, once again, it doesn't matter how well you actually do, so long as you learn something, then you would not have wasted your time. Yeah, so Saknik sends Sama. Ken's 2 question 3 was thinking along the lines of an event queue, couldn't find the logic of getting back to finding the minimum number of queries. So I also did something similar to an event queue. Yeah, I also did something similar to an event queue, and I got stuck because there are a lot of events in the queue. I think that's where the binary search comes in. Not super sure. Yeah. Yeah, but we'll talk about it in any way. At any rate, let me come up with the script, do the YouTube thing, and then we'll get started with the discussion. So, we are discussing solutions for LeetCode Weekly Contest 424. Jump to specific questions using timestamps in the video description. Please check out the rest of my channel if you enjoy LeetCode content. Like and subscribe to stay up to date on new video. Let me know how well you did for today's contest. I'm always curious who managed to finish all 4 questions or not. What you found easy, what you found hard, what you like or dislike about the contest. Just drop a comment and let me know. All right, so let's go over answers for today. Today I think question 1 is quite easy. Question 2 and 3 are almost the same. 3 is surprisingly difficult, and question 4 I unfortunately was not able to try at all. I will try to talk a little bit about it based on what my guesses are, how I would think about it, but we will walk through them one by one. Let's start with question 1. So question 1 is make array elements equal to 0. Let me refresh this. Yeah, I just realized that, yeah, oddly enough, all 4 questions are about the same theme of reducing things to 0. So, question 1, you're given an integer array nums. Start by selecting a start position cur, such that nums cur is 0. Find a 0 within nums, and choose a direction, either left or right. After that, you can repeat the following process. You can, if cur equals 0, move in the current direction by incrementing cur if you're right, or decrementing. So if you're currently in a 0, actually let me draw this. So this is a bit of a reading comprehension question, so I want to draw it out so people get it. Let's take this example. I feel like just reading out the question will not help. Okay, so I'm going to start by going to a place, let's say here. Okay, so pick a direction. Let's say I pick this direction. So what I'll do is I'll come here, 2. I'm going to replace 2 with 1. And I'll come here, and it says here the rule is if it's 0, keep going. So this is 0, keep going. If it's not 0, then decrement by 1 and reverse direction. So it's like a ping pong. So from 0, I'm starting from 0, move left. I move left, hit this 2, send it back to 1, and then I'm going to ping pong back. And I say hit this 3, it goes to 2, and then I ping pong back here. This 1 becomes 0, and ping pong back here. This 3 becomes 1, and ping pong all the way here. Now these are 0, 0, 0, right? All 3 are 0. This becomes 0, and ping pong all the way back here, and this 1 becomes a 0. So basically, it's like a game of game of pong. If you're familiar with game of pong, it goes left first, and then right first, and then left, and then right, and keep decrementing numbers. It ignores the 0. It goes to the first non-zero number, decrement it, and then it like sort of bounces back, goes in the opposite direction. So it's like a ball, left, right, left, right, left, right, forever. So you want the whole thing to be 0, right? When will it not be 0? When will it not end up with 0? If it's something like this, it's not going to end up 0. Because let's say you start here, you go here, this becomes 2, go here, this becomes 0, go here, this becomes 1. Whoo! Now it goes infinite, and this 1 never goes to 0. So you'll not become, this will basically be invalid. This will be an invalid combination. Okay, so this is, this question is not really a programming question. It's a reading comprehension. First, you must find out what it's doing. Secondly, it's sort of like a math problem. So if you think about it, the way to make sure that this thing actually bounces correctly is you start with a 0, where the total number of sum of numbers on the left and sum of the numbers on the right are equal. So this is 3, 2 plus 1 also 3. So it's going to bounce left, right, left, right, left, right 3 times, and everything will be cleared. And because this is because they're both 3, you can go to the left, you can start by going to the right. It doesn't matter. Okay, if, for instance, this thing is not a 3, if this thing is a 2, then you have to start from right, from the left. You have to bounce this to 1, bounce this to 1, bounce this to 0, bounce this to 0, and then bounce this all the way to 0, and you'll still get 0. So if the sum of the numbers on left and the right are different by 1, then you have to start going towards the side with the slightly larger one. If they are equal, then it doesn't matter which side you go. So there you have it. That's basically the way to calculate. So I have a count. I have a total. I'm going to add everything up. I have a count of how many valid selections there are. So for any numbers, if n is 0, I'm going to check. If total equals to current, times 2, which means that I am right smack in the middle. The current is everything on the left, and total is the whole thing. So if everything is on the left is exactly half, so everything on the left and right is equal, then I have count plus minus 2, because if I start here, I can bounce in either direction. If the difference is 1, then I can only bounce in the direction that's bigger. So count equals plus minus 1. If it's not equal to 0, then current equals current plus n. You add the number. So current basically counts what's the sum of the numbers to my left. Total is the sum of the whole thing. So that just total minus current tells me what's the number right. And then you have count. So this is kind of a fun little logic puzzle question, but it's not really programming. Okay, cool. Okay, so question 2, zero array transformation 1. Let me just dump this. You are given an integer array nums. Let me just refresh to show my code. You're given an integer array nums of length n and a two-dimensional array queries where queries equals I left right I right I. So for each queries I, select a subset of indices within this in nums. So basically for each query, decrease the values as select index by 1. So basically for each query, L and R, go from L all the way to R and decrease all their values in nums by 1. Okay? And the question here is, once you're done with the queries, do you get 0? Now, there's one thing that they wasn't very explicit about it, which is if the selected index value at the selected index is already 0, you don't decrement it. You just leave it at 0. Okay, so run through an example. For example, this example is 1, 0, 1. So the first let's do this example. So this example is 4, 3, 2, 1. So the first query is 1 to 3. These are the indexes. So 1 to 3. 1, 1. So 1 to 3. And then the second number is 0 to 2. 0, you minus 1. 1 minus 1, 1. Okay, and you can see after you minus 1, this is left with 3, this is left with 1, this is left with 0, and this is left with 0. So this is not a 0 in the array. This is not a 0 in array. Conversely, if I start with nums 1, 0, and 1, the queries are 0 and 2. So 0, these are the indexes, 1 and 2. So this will be 0 left. This will be 0. It's minus 1, but who cares? So it doesn't decrease below 0. That's something implicit in the question. So this is 0, 0, 0, which is a 0 array. And so this is true. So select subsets, yeah. So this is a pretty straightforward question. Now, the main thing to note is that if you do it naively, if you go through each query and you physically subtract 1 from all of these numbers, you would time out right away because you would have O(n) squared. The number of queries is n, and the length of nums is also n, so O(n) squared. That's going to be too slow. Instead, what we're going to do is we're going to use the prefix sum method. We're going to use something akin to a prefix sum to help us. So what we want to do is, let's say 4, 3, 2, 1. We're going to start with 1, 3 first. Actually, we're going to ignore the 4, 3, 2, 1. We're going to start with the queries first. So queries, let's say 1, 3. It means that at 1, I get a plus 1, right? I want to count how many decrements you have. I have 1 decrement if I start. So everybody after 1 gets plus 1 decrement. And everybody after, well, I guess 3 is the end, right? So there's no minus 1. So same thing, this 0, 2. Everybody starting from 0 gets a plus 1 decrement. And then after 2, which is 3, you get a minus 1. Which means the maximum amount of decrement that happens at index 0 is 1. Here 1 plus 1 is 2. 2, nothing happens, is still 2. And then 3 is 1. So your queries will basically decrease index 0 by 1, index 1 by 2, index 2 by 2, index 3 by 1. So this is faster. This is much, much faster because this is essentially doing a prefix sum calculation instead of doing O(n) squared calculation. So Yeah, because each query you just calculate the beginning and end. So basically, this is what we want to do. We're going to create, so what we have here is we create a start. So start is all the pluses. We have end, all the minuses. So we go through all the queries. We go to start L plus equals to 1. And we go to all the ends. If the end is the last element, then it basically never ends. If it's not, then we find the place where it ends, so R plus 1. And we say minus 1 there. So once we've done this, it basically tells us the start and end. And then from there, what we do is we keep count of current. This is basically like a prefix sum. It's the same idea as a prefix sum. When you see a plus 1, you just add 1 to it. You plus 1 again, it becomes 2. If there's another plus, then it becomes even more. And minus 1, it goes back down. And you keep track of the prefix sum, and you check that the prefix sum is the prefix sum, if it's ever smaller than the current nums, then return false. So for instance, this one is 4321, right? 4321, this is nums. Four is larger than 1, so this is already straight away false. This is okay, but these two are false. So in fact, if you validate this actually form, you get 3100, which is a 3100 you see there. Yeah, so this is basically pre-standard prefix sum problem. Okay, all right, I don't see any questions. Okay, question 3. Question 3, zero array transformation 2. You are given an integer array nums of length n and a 2D array queries, blah blah blah. So this looks like the same thing, except that instead of 1 each time, there's a val. So you don't subtract 1 each time. You can subtract val. Decrement the amounts by at most val. Well, you just decrement by val. You just like straight up decrement by val, since you can't decrease it below 0 anyway. The amounts by which each value is incremented is chosen independently for each index. Zero array, blah blah blah. So this is the part that is really different, right? First of all, this val is pretty much the same thing. So here, instead of +1 -1, you just change this to val. That's all. But this part is the one that's different. So instead of returning whether the queries, all the queries will clear the nums and turn it into a zero array, what you want to do is to return the minimum possible non-negative k, such that after processing the first k queries, nums becomes a zero array. So what you want to do is you want to say, okay, cool. What you want to do is to say basically, okay, cool. What is the smallest value of nums? The smallest value of k. I don't want to use all the queries. I just want to use the first k queries. Am I able to get this within the first k queries? So here's where I got. I didn't actually complete this, but this is where I got. So the idea is very similar to the first one. Yeah, let's use this as example. Let's use this example. The idea is very similar to the first version, except that this time you don't just keep track of the value that you can increment or decrement. You also keep track of the index. So for instance, I can see at 0, this 0, 1, 2, right? So 0, 1, 2 means that 0, 2, 1 means, and this is Q0. So Q1 is 0, 2, 1. Q2 is 1, 1, 3. Just to make sure, yeah. So I'm going to keep track not just of the number, but also the index. So for instance, this is 0, 2. It's basically all 3. So you get +1. So here you get +1 at query 0. At query 0, I get a +1. If my k is 0 or more, I get +1. Okay? And here, because this goes all the way to the end, you don't have the -1. But for sake of completeness, -1. So same thing, this is at query 1, you get a +1 at index 0. At query 1, you get a -1 at index 3, which is the end. And this at index 1, for query 2, at index 1, you get a +1. Index 2, at query 2, you get a, what do you call it? Oh, you get a +3. You get a -3. So you have something like this. And the basic idea that I tried is basically I go through each number. So this is 2, 0, 2. I go through each number and say, okay, at this index 0, which ones of these do I need to take? I need to take both of them. I need to take both of these pluses in order to be at least 2. I need both 0 and 1 in order to be 2. So my k at here is equals to 2. I need 0 and 1. So here, my current, I already have a +2. So my current, I don't need anything else. So my k is still 2. I don't increase my k. And here, you know, my k is still 2 because I already have 2. And then here, I don't do anything. So this will give me the answer 2. Or it should give me the answer 2. Yeah, so k is 2. So that's the basic strategy behind it. Yeah, but the problem is I think what I ended up doing is that this become very big. Like this thing. I essentially did end up having an n-square algorithm. So this becomes very big and then it doesn't really work. So I think what someone else in the chat did is they did some kind of binary search. And I think that should be able to do it. I will have to investigate a little bit more. I will have to investigate a little bit more on my own time to see whether that's the correct solution. Okay, so question 4. So question 4, I didn't manage to do it. I ran out of time on question 3, but let's go through the idea behind it anyway, or at least what I think the idea should be behind. So question 4, minimize the maximum adjacent element differences. You're given an array of integer nums. Some values in nums are missing and are denoted by -1. So you can choose a pair of positive integers, x, y, exactly once, and replace each element with either x or y. You can minimize the absolute difference between adjacent elements of nums after replacement. So for instance, actually, I have to complain. The examples are quite bad, you know? The examples are kind of sus. So let's say, for instance, in this, you have -1, 10, and 8. This -1, you know, I'm just going to replace it like x. Okay? You can choose two numbers, a and b. Let's say, and what you want to do is to minimize the difference between them. So 1 and 2, the difference is 1. 10 and 8, the difference is 2. These things can change. They are fixed. 2x and 10. How do I minimize the difference between adjacent? How do I choose a number for this question mark here to minimize the difference between this pair and this pair? Well, I'm just going to divide by 2, right? So the best way is 10 minus 2 divided by 2, which is 4 plus 2, which this will be 6. So if I have one of them as 6, the other one as whatever, then this will be 4, and this will be 4, and this will be minimal. And that's why the output is 4. That's the idea behind it. Let's try another example. So this one is all -1s. So all -1s, you can choose any number you want, you'll be happy. And then this one is more interesting. This one is basically, so x 10, x 8. I could choose A and B equals. So how do I minimize x and 10 and 8? Well, the difference between them is 2. So I'm going to take 10, 2 divided by 1, and this should be 9. Add to a smaller one, this should be 9. Okay, so this would minimize the difference between them. What about this one? Well, this one, the smallest one is you can actually make it 10 if you want. I will make it 10. So if I replace this by 10, this and this is 0. So this will be smallest. In this question, they used 11 instead of 10. It doesn't matter. But, 10 is slightly more correct. So this is basically what the question is asking for. Well, I feel like there's a few things to consider here. One thing that jump out at me right away is that it doesn't matter how many x's there are. Let's say this is 2, x, 100. Right? These x's have to be A or B. So what's the difference? How do you minimize the adjacent? If let's say this is A, B, B, these two are 0. These two are 0. This is B minus A. And this is A minus 2. And then this is 100 minus B. So if you have, it's going to be exactly the same. This is A minus 2, B minus A, 100 minus B. Whether this is 2 x's in between 2 numbers or it's a lot of x's, it doesn't matter. Because if you look at the adjacent pairs, you try to minimize these 3 things. So in a sense, you can only look at you can ignore those, like you can ignore like this or 99. You can ignore all these things because they don't matter. You can't control them, right? You can only control this sequence of x's. So essentially, first step, I would identify all the sequence of x's. If the sequence of x's is more than 2x, then it doesn't matter. If the sequence of x's has 1x, or if the sequence of x's is like at the beginning, like this one, like this one, this will be 10. Right? If it's at the beginning, then again, it doesn't matter how many they are. You just make them all the same number. So I'm going to identify what the constraints are. And I'm trying to solve for the constraint. Now, the tricky part here is that the tricky part, of course, is that you only have A and B, and you have to use them everywhere. Solved it using segment tree with lazy. Oh, nice. Wait, so Figman, are you talking about question 3 or 4? Sorry, I missed it. If you solve question 4, that would be pretty amazing. Well, this is how I approach it. I'm going to identify all the different like types of intervals. So I have like interval that is, I have 3 types of interval. One type of interval is an edge. One type is between, and there's 1 x in between. 2 between. 2 between is like this, or 2 or more between, or 1 between is like, this is how I will conceptualize it. Yeah, and then I have the numbers before and after it. So from there, I will try to figure out what are the possible values of A and B that will minimize the difference, absolute difference between them. This is actually not that easy because you have to use the same A or B. There can be a lot of x's, right? There can be a lot of like 1x, 2x, 10x, 50, x, 1, x, 12. There can be a lot of x's. All the x's must be the same pool of A or B. So this is a bit tricky. I have to think about it a little bit. I got to think about it a little bit. Yeah. Yeah, I gotta really think about it a little bit. Basically, you have to minimize the absolute difference between all these numbers. And then figure out the constraints. Actually, this doesn't even matter. Yeah. Yeah. You figure out the constraints between them. So actually this 1 between or 2 between doesn't matter. Because these numbers are either A or B. Yeah. I'll think a little bit on this. I gotta think about this a little bit. So unfortunately I wasn't able to tackle this question while the contest was running. But I hope that some of you are able to. Q3, yeah, very nice. Segment 3, lazy. I will try it. Yeah. Segment 3 with lazy sounds like a promising direction. Well, I will try it. Yeah. Let me see if there are any questions in the chat. Yeah, if not, then I think that's about it for tonight's live stream. I will take a look at question 3 again to see how to do it. Comments on how well you did. Yeah, Figman, do you manage to solve all 4? If you did, congratulations. If not, if you solve question 3, that's still pretty cool. Either way, I think that's all for tonight's live stream. Thanks a lot for only 3. Well, that's still pretty good, you know. I will give you a congratulations. Yeah. So I think that's it for tonight's live stream. Thanks a lot, everybody, for tuning in. And thanks for the heart. And remember the comments on the VOD when it comes out. If you enjoy my content, make sure to like and subscribe so you know the next time I'm streaming or post a video. Thanks, everybody. Good night. I'll see you next time.